Hello, welcome to class. Today is April the 25th. It's Thursday. I'm going to go through the answer keys to assignment 118 today with you. I'm going to do this pretty fast so the video is not super long, but you're going to need to stop the video on each page so that you can look at the answers and analyze those. If you have any that you're not sure how I got the answer that I got, I would recommend checking in with your neighbor or someone at your table. If you still can't figure it out, put a circle by it, and we will have time to answer any short questions tomorrow before the quest, which is tomorrow in class. It's only about 22 or 23 questions. You'll have plenty of time during class to do that, even with grading today's review assignment. Don't forget that tomorrow is the day IXL skills are due. So you can also be working on those should you finish everything in class today and need something to work on. So let's begin by looking at key 118. This was that 4-page review that you've been working on for the last 2 days in class. It began with some counting principles. Remember, whenever you're doing the fundamental counting principle, it's outcomes times outcomes. So you want to know how many outcomes there are for each event. Please, tomorrow, make sure you show your work as I've done here. If you didn't show your work on your worksheet like this, you might not have gotten full credit. But I know you can do 4 times 3 in your head very quickly and simply, but I need to know what you are referencing for each of your values there. Here's the rest of that. I like these questions where they didn't just give you the numbers. You had to count out the numbers and figure out exactly how many there were. Especially like letter A, had to keep math or English, and then the 4 other classes they could choose from. So that is the first topic on the quiz tomorrow. And we're calling it a quest. It'll go in the grade book at about, I don't know, I think 60 to 70 points. I can't remember off the top of my head right now. Next thing we learned to do is use a experimental or a theoretical probability to make a prediction. And this reviewed us using proportion thoughts, right? We worked on proportions during camp week, right? So you have a set amount. So this is on a roll of pennies. You also could have done a roll of 50 pennies, purchased at the bank, 16 have never been used before, or are newer than 1963. That means there's 34 older. Right, and then it said that's just some details about the roll of pennies. 4 rolls of pennies are purchased. So since this is in rolls, I'm not going to use 50 because I'm going to use the roll concept. Right, 10 rolls, again, it's in rolls, so 16 to 1. 20 rolls of pennies, make sure you read that carefully. That's why we're using 34. The whole 50 pennies didn't really come into play. You could have converted them all to 50s, but then you would have needed to convert 4 rolls to 200 and 10 rolls to 2,000 and had some much bigger numbers. You still should have gotten these same answers there. Lots of people struggled with the hat. This is an experimental probability based on 1 day's sales. 12 hats, red, 3 white, and 10 black in 15 minutes. So how many hats did they sell in that time? They sold 25 hats. Predict the number that were red. How many out of 1,000 were red? So you would use this 12/25, which was an experimental section of time, 15 minutes, to make that prediction. This went on for 7 days. Each day the same things were sold. How many were the white? Right? So here's what I did for the white per day. And white per day was 120, and 7 days, that's how I got to 840. Not red would be everything but red. So you could go through there and figure out how many that would be. And then that would be, you could do the complements. Those 2 things had to add up to 1,000, 480 and 520. But then you needed to multiply that by 10 because we're talking 10 days. And then finally, all of this information was given in minutes. We had to move to hours. So you needed to make sure that you converted those times over there in making those predictions. I'm going too fast. Pause the video until you have your answers done. and then restart. All right, the next page is talking about independent probability. And remember, independent means one event does not affect the other. So spinning this spinner and spinning this spinner has no outcome that affect each other. Getting a white, 1 out of 5, and then an A, 1 out of 3. I'm just simply going to multiply those two together. Find each individual probability, multiply them together, reduce if you can. That's independent is really just doing like simple probability twice. Same thing with rolling this, spinning this spinner and rolling this cube. Please, again, on the quiz, show your work. You'd be amazed at how many people make silly mistakes. 1/4, 1/6 would be 1/24th, and 1/4, 1/2 would be 1/8. 3/4, 3/6. Don't worry about reducing them. Just write them down and then reduce as you go. 1/2 and a 6, and so on. I like these ones. Not. Remember, that's everything else. Blue would be 1 out of 4, and not a 2 would be 5 out of 6, and that's how you get to those answers there. And here's the key here. Find each probability. If you pick one marble and you replace it, when you go to take the quiz tomorrow, read the scenario well. Taking the marble out makes it a whole different probability. Leaving the marble in or putting it back changes everything. So we're going to have 1 6 times 2 6 and 2 6 times 3 6. And again, I would write them down and then I would reduce. Show me that you understand how we get to each of those. I don't remember the puzzle. I think puzzle's a play on word for handcuffs. Handcuffs. Funny, funny. 2 multiple choice questions, 5 each. So you have a 1 in 5 chance on the first and a 1 in 5 chance on the second. That's how you get to 1/25th. The last page was dependent probability. And this is the one that probably requires the most thought, working ahead, and pre-work. Because what happens on the first one, right? And the key to independent probability is you do not replace it. So we have 8 cards the first time we pull out, and then you would have 7 cards, and then you would have 6 cards, and then you would have 5 cards, and so forth. Each letter of the word bananas is written on the card. Find the probability of picking 2 cards without replaying the first. And again, you have to make sure that you always assume the first happens. Okay? The key to this is you assume the first event happens. So when it says black and then white, you would assume that you drew one of these black cards, which is why when it says white, then white, it's 3 the first time and 2 the second. Not possible to draw B then B. That would be called an impossible event. Six purple socks, 4 orange socks, and a drawer. So you picked one sock without looking and then picked another. So you'd have 6 purple. And again, you assume purple got picked, so you'd have 6 out of 10, and you'd have 5 out of 9. Because you always assume the first event happened. Making sure you have those good for binder check, because we will have one final binder check this year before the end of the quarter. And I can't remember the silliness here, but it was a crime wave. I think a bunch of robbers in the sea or something, criminals in the sea, a crime wave. Can't remember. Okay, what I have next for you is just some probability practice. So you can sketch this anywhere. It's not really going to be notes. It's just some practice problems that would be good for you prior to taking your quest tomorrow. So first one, 10 events are described below. Decide which column or table they would belong to. So what I would do is draw this little chart. impossible, not likely, equally likely, likely, or certain. And then we're going to place these items in there. So you will win a grand prize raffle if you purchase 2 out of 100 tickets. That means your chances of winning would be 2 out of 100 or 1 out of 50. Hopefully we all know that that would be unlikely event. So pause the video, go through A through J. You don't need to write those down, just write where A, B, C, D, and so forth would be. And restart that video when you're ready. B, you wait less than 10 minutes before ordering your food. The whole point of a fast food restaurant is that you order it quickly. That would be likely. You get an even number when you roll a standard number cube. That's going to be equally likely. There's an even number of odds and evens. A 4-year-old is over 6 feet tall. I'm assuming they mean this is definitely an impossible event. I know everybody's like, oh, there's this one person. I'm not sure over 6 feet tall at 4. Nobody in your class is late to class next week. No one in your class is late to class. Like that event happening that somebody's late. It kind of depends on my classes. For a lot of my classes, that would be likely. I very seldom have people late to class. If you had a class where lots of people were late and somebody was late every day, that might be something that would be unlikely. The next baby born at the hospital will be a boy. Hopefully we all agree that will be 50%. It will snow at our school on July 1st. Again, that's not going to happen. It's summer, too hot. Sun will set before 11 p.m. That is always going to happen. No matter where you're at, the sun sets before 11. Spinning the spinner will result in a green. Green is equally likely. And spinning the spinner will result in a yellow. That would be called an impossible event since yellow is not on the screen. All right, a spinner with different colors is spun 20 times. The data of each spin is recorded below. What is the sample space of the spinner? So let's review what sample space is. Remember, sample space is the total outcomes. So looking through my list, my sample space would be red and green and yellow and blue. And are you done yellow? Are you done red? Yellow, green, red, yellow, 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 green, red, red. Looks like this is it. Does it seem that each color is equally likely? Explain your reasoning. Now, if I had to analyze this, I would probably do some sort of tally. Red, green, green, yellow, yellow, no, yellow, blue, and then another tally for yellow, another tally for red, another tally for yellow, green, red, 3 yellows in a row, and a green, and 2 reds, and another yellow, and a green, and a red, and a yellow. I would say no. Very few blue. I don't know what it looks like, but I would bet there's 2 sections of yellow that are bigger than the others, and or the same size as all of them, but 2 yellows, a green, and a red, and then only 1 blue. Estimate the probability of spinning each color. How do you find the probability? Well, it would be how many you got. So there were 6 reds. That'd be 6 out of 20, and you would reduce that. 5 out of 20. This would be 8 out of 20, and a 1 out of 20, based on your sample space and your results. Spinners divided into 5 equal spots. 300 spins. These are the outcomes. It's nice when they tell you, but remember that would equal 300. Estimated probability of it landing on an even number, so you would check your evens. 66 and 72. 138 out of 300. That would be your probability. You should reduce this or turn it into a percent or a decimal using your calculator. Finally, we have a tally chart. Don't forget to study the deck of cards that's on the back of your probability notes, the very first set of notes we took in this unit. We wrote down exactly how a deck is made up, 4 suits. So 52 divided by 4, and that's 13 cards, and continued on. But this doesn't want my theoretical. Remember, theoretical is what should have happened. They want it on the results, so that means we're doing experimental if we're doing it on results. Based on her results, the experimental probability of selecting a heart. First thing we gotta do is figure out how many pulls did she do. Doesn't tell me. Don't think she did 52. 52 is the cards. She did 5, 10, 15, 20. 25 looks like she did 30 pulls. Experimental probability of pulling a heart would be 9 out of 30. Always reduce. I encourage you to write the original in case you mess up reducing. 3/10. Theoretical probability would be 13 out of 52. Right? You could compare these. If I said compare them, make them decimals to compare them. That would be the easiest way. This would be 0.3, and this would be 0.25. So we got a little bit higher in experimental than we should have, but they're really pretty close. What's the experimental probability of selecting a diamond or a spade? So diamonds was 7, and spades is 11. So that would be 18 out of 30. And again, reduce by 6 would give me 3/5. So that's about 60%. That would be higher than we would think because diamond or spade would be half the deck, 50%. That's the next question, right? 2 suits would be 50% because each suit's a fourth of the deck. Comparing these results, my experimental was a little higher than my theoretical. Okay. For the class today, you're going to work on assignment 119. It is a probability review over all things. Use your notes. Make sure you're good. We're going to correct that tomorrow in class right before we take the quest. Make sure you have it in there, and then your quest will be over those. Like I said, about 22 questions. You're going to have to make a tree diagram on the quiz, on the quest, and answer some questions about vocab, sample space, what's an outcome. Going to do some very basic probability. You're going to label events, independent and dependent. And that'll be about it. There won't be any homework tomorrow after the quiz. And then we'll talk about iLearn on Monday in preparation for the math iLearn next week. And we'll go from there. Have a good day. Thanks.